We've had Battleborn lithium batteries installed in our RV for the past 12 months, so we've come to Reno, Nevada to find out exactly how they're made.
If you're new to this channel, I'm Diana.
And I'm Matt.
And we are on a quest to visit all 419 National Park units.
So let's head on inside and see the factory.
Hey Matt, welcome.
Good to see you
nice
again.
Nice to see you. I am the CEO of a company called Dragonfly Energy, hence the backdrop.
Yep.
And our brand of batteries that we sell into the aftermarket is called Battleborn batteries.
Gotcha.
So that is the connection between the two names.
And we're big fans of your product. We've had Battleborn batteries in our RV now for 12 months and they have been amazing.
Glad
I'm
to
sure
hear
we're
it.
not the only people that have had a story like that though.
You are not, no. We have had quite a lot of attention for what we're doing here. And our main goal has been to displace lead acid batteries, especially in RVs, but really in any situation where people are trying to get off the grid.
Gotcha. And what are some of the stories you've heard back?
It's a lot of fun hearing from our customers because, across the board, we have a very common theme from what we hear back from customers, which is basically that it's changing the way that folks are able to live off-grid in their RVs, on their boats, or just any sort of situation where people want to get away and still sort of enjoy the amenities that they're used to at home.
Yeah.
So basically, the switch over from a lead acid battery to a lithium battery allows you to do things like draw more power than you used to be able to do.
Gotcha.
This is a game changer in terms of lifestyle, in terms of what people are able to do.
Yeah. And we've seen that firsthand. It's been incredible, like you say, to live almost off grid without sacrificing any of those norms that you're used to anymore.
Right. Well, I mean, I'll give you just the biggest example, I would say. This is always my favorite thing, is when people come in and they're like, hey, for the first time, we're able to use our air conditioner, right? So a lot of people like to go boondocking where it's warm. They go boondocking in the desert, or and the fact that you don't have to start a generator and you can continue to enjoy your surroundings and nature, and you can fire up the air conditioner.
That's pretty awesome.
Or you got dogs and you want to go for a hike and you leave the dogs.
Yes,
who would hike without their dogs? Well, let's say the little dog doesn't like to hike.
Yeah.
The fact that you can actually rest assured you can leave the air conditioner on, and the power and the energy storage allows you to basically enjoy that. You couldn't do that previously.
It's so true. It's so true. And tell us a bit about where we are right now, because we're somewhere a little bit special, aren't we?
Yes, actually, what a coincidence. You showed up at our production facility here in Sparks, Nevada. I think a lot of folks are used to hearing about Battleborn batteries made in Reno, Reno, Nevada. We moved not across town to the next town over, a place called Sparks. Which is
fitting for a company that makes batteries, that you should be in Sparks.
It is, absolutely. It makes sense. And we basically needed to get a larger facility. So we had the last place we were in for about 3 years, and we thought we would be there longer, but things actually grew a lot faster than we thought it would. So we moved into a place now that's about triple the size.
Wow.
And we're going to, more than triple our production capabilities here.
That's fantastic. That's absolutely awesome. And how long have you been here now?
Just a few weeks.
Yeah,
you caught us right at the beginning. So we're still moving in, kind of. We're in full production, but we're still moving in.
Well, I'd love to take a look around if we can.
Absolutely.
So Dennis, you've brought me through here into the factory floor. This is where the batteries are made, is it?
This is it, yeah. So we actually just walked through sales. We've got all our administration and marketing and HR, everything is in the offices back here. In this particular area, we store sort of our accessories. We sell, as you know, we sell a lot of Victron stuff. We sell some Magnum stuff. We sell Progressive Dynamics, a lot of accessories to design whole systems for people in addition to the batteries.
And so you keep all that stock here as well?
Keep all that stock over here. We've got engineering back there. That's where we do all of our product design work and stress testing.
That's the research gurus and things like that.
Actually, we've got an R&D facility which is off-site. So that's not here. And then the whole rest of the area here is the production. Well, this is the first part of the assembly process, which is where we take the individual cells that have already been cycled and sorted, and we spot weld them into modules. So for example, if we're making a 100 amp hour battery, we spot weld 30 of the 26650 cylindrical cells in parallel into modules. And that's what's done here. So this is a spot welding station. This is all automated. We've got obviously some manual preparation in terms of loading the cells into jigs. And then we actually put them into the automated spot welding machines. Once we have the mods, then we need to cycle the mods as well. And
so you take each pack and then run that through the cycle together?
Yeah, so I'm calling them mods. They're modules. They're basically groups of cells in parallel. So we take the modules, the 100 amp hour modules, and we put them in cyclers. And these are also homemade. The cyclers will take the modules, bring them all the way down to empty, as specified by our battery management system. Empty is, 2.2 volts. And then all the way up to full.
These are 100 amp hours, but they're not the full 12 volts at this point. These are like
That's right.
3 point.
That's right. They're the individual cells.
Gotcha.
The individual cells are at 3.2 volts. So those are cycled between 2.2 volts and up to 3.6 volts, and the capacity is measured. Then what we do is we take all the modules out of the cyclers, put them on a sorting table, and we sort them by capacity and make sure that when we make a pack filled with 4 modules in series, that the variation is not more than tens of milliamp hours for a 100 amp hour battery.
So you haven't just kind of like bought these cells, put them together, and then just assumed everything's going to work. You've rigorously kind of gone through and measured everything then.
That's right. So every individual cell is cycled and every group of cells is cycled, and then they're grouped by capacity before they're assigned a serial number. So once they're grouped, then they're assigned a serial number. It depends whether it's a 24 volt battery, 100 amp hour, 50 amp hour. There's different sizes of modules. And then once that's done, every battery management board is tested and mounted onto the modules. And
so tell me more about the battery management system. What does that do? What's its role?
So the battery management system, everybody has their own battery management system. So we have our own. We designed our own battery management system. We contract out the manufacturing of that since we don't have any capability to make electrical circuits here. But what ours does, which is unique, I think, is it actually monitors the voltage, current, and temperature, and also the time that current's been applied. And we allow a variety of different levels of current. For example, our 100 amp hour battery can do 100 amps continuously from full to empty. It can do 200 amps for 30 seconds, and it can do up to about 500 amps for half a second to allow you to crank.
And help me just understand why can't it always be 500 amps or always be 200 amps? Why do you have these different levels?
Yeah, so the cells are capable of delivering a very high power, but it's not just the cells. It's also the protection. The battery management board itself has circuitry in it that cannot allow unlimited current. It's also the connections. It's also the terminals. All this stuff.
So it's a bit of a safety thing for everything.
Absolutely. I would say not just safety, longevity. We're trying to make a product that will last a very, very long time, decades. That's the point. Why do you buy a lithium battery? I feel there's plenty of reasons. One of the reasons is because it lasts so much longer. You don't have to worry about it. And a lot of that has to do with how well are the currents controlled.
And then tell me a bit more about the capacity. So you mentioned 100 amp hours before. If I go down to Costco and I buy an 80 amp hour battery, I can only really use 40 amp hours before it starts to damage the battery. That's not the same with lithium though, is it?
That is not the same. So you can use the entire 100 amp hours of every battery. So it will allow you to go down to a certain voltage. That's what the BMS does. And at that voltage, you will have used at least 100 amp hours. So you can safely use the entire stated 100 amp hours. The other important thing is...
And continue to reuse it, like time and time again.
Absolutely, yeah. There is some degradation. For example, if you're cycling... We've measured in our in-house testing that the 20% degradation, so once you go from 100 amp hours to 80 amp hours, that happens somewhere between 3,000 and 5,000 cycles, depending on temperature, depending on charging current, there's a bunch of
So in other words, if I took a battery and I went from 100 down to 0, 100 down to 0, 100 down to 0, repeatedly, after 3,000 to 5,000 cycles, I would have lost about 20% used capacity.
That's correct, yes.
So if I used my entire battery pack every day for 10 years, I would still have 80% of its life expectancy left.
More or less, yes.
Wow.
There's also some natural aging that happens. So it's not just cycling, but just sitting around, there's some aging, and that could be something like 5% for a decade.
So compare that to a lead acid battery that might have a couple of hundred cycles. Or
there's no comparison. Yeah, I mean, we're talking like the degradation rate is so small when you compare to a lead acid battery where, for example, if you mess up and go below 50%, then you've done damage there as well.
Damage.
I want to also say that it doesn't matter if you cycle the battery, a lithium battery, at a 2-hour rate or a 20-hour rate, you still get 100 amp hours.
So if I'm using my AC and really working that battery hard, that's not a problem. It doesn't hurt anymore.
No, if you did that with a lead acid battery, you wouldn't even be getting the 50% of the stated. So yeah, it's a big difference.
And then every battery that leaves here, then you're basically guaranteeing has at least 100 amp hours of capacity, because you've tested the cells and the modules and the battery itself, right?
That's right. So we match them, but because of the fact that we match them based on capacity, means we know the capacity of every battery.
Yeah.
And our capacities generally range between about 103 and 108. So we do get a variation of pack, and that variation occurs because we don't mix up capacities. You know, the fact that we keep everything identical actually amplifies the variations in the packs at the end. So we've got about a 5% variation, but they're always over, at least 102, 103 amp hours.
Wow. So if you buy a 100 amp hour battery somewhere else, say a lead acid one, you've only got half of that. Here, you may have even slightly more than 100 amp hour.
Yeah.
That's pretty cool. That's pretty cool.
We over-deliver.
So tell me more about the battery management system. We've been through this, so I kind of know what happens. But for some people out there, if I take my battery all the way to zero, it's not going to damage the battery. But tell me what happens when I get to zero.
So when you get to zero, and by zero, we're defining zero as when the battery management system cuts off. Cuts off. So it prevents discharge. So that's exactly what happens. It will no longer allow you to discharge the battery. In our battery management system, we can distinguish between charging and discharging. So you can always charge it up, but you can't discharge it. So practically what that means is if you try to measure the voltage of a battery pack in low voltage disconnect, just measuring the voltage requires a small amount of discharge, and it won't let you do that. So the voltage you measure is meaningless.
So it basically 0 volts almost.
It'll say something like 4 volts or just 6 volts, something meaningless. So the battery is probably at 10 volts, something like that, but you can't access that. If you just give it a voltage, give it 12 volts, it'll take the voltage and start to charge the battery. So that's something that it's kind of a nuance with lithium batteries, is that if you have a solar charge controller and that's the only way you're charging the battery and you're in low voltage disconnect, the solar charge controller won't necessarily know there's a battery there.
So it won't give any charge out.
That's right. You got to kind of trick it. Give it 12 volts from another battery source, another DC source or something.
And that's exactly what we did with ours. We ran it down. We had a few cloudy days in a row. And we thought, let's see what happens when we get to absolute zero, basically.
Right.
And at 5:45 a.m. in the morning, after several cloudy days in a row, we eventually hit zero. And like you say, everything just stopped. Everything cut off. And we had to give it the kind of little 12-volt jump starter pack to get it going again.
Just momentarily to get your solar charge controller to kick in.
As soon as we touched it, bing, came back to life, and the solar panels kicked in, and it all started working again.
That's right. Yeah, that's it.
And so the BMS then, the goal of this BMS really is to protect the entire system. It's not going to stop anyone vandalizing the battery or something, but in all usual situations, that's there to protect the battery.
It's there to protect your investment. That's exactly it. So if the battery goes down into low voltage disconnect, it's been disconnected for a reason. If you try to discharge it more, you can damage the battery. So that's what it's there to prevent you from doing. I will say this: if you have a battery in low voltage disconnect, don't leave it like that. Don't store it like that, because there's a natural bleed.
Yeah.
It's it's way less than a lead acid battery, but the self-discharge of a lithium battery is about 2 to 3% per month capacity.
Wow.
So
low, but not zero.
It's not zero. So if you're in low voltage disconnect, it will continue to bleed a little bit.
Gotcha.
And then it could take you down to regimes where either it doesn't power the BMS anymore, or it will damage itself, or the cells can get damaged. So that's the only thing we ask.
Give it some charge. Give it some love.
Give it some love. Just give it some love. If you're gonna store the battery, just don't store it empty. Give it half charge or something.
And then one of the other questions that we get a lot is about temperature. And we often hear people say, I really want to put lithium in my RV, but I've heard that you can't use lithium in cold temperatures. Can you tell me a little bit more about that? What are kind of the risks with cold?
I wouldn't say you can't use them in low temperatures. You can always discharge the batteries in low temperatures. At freezing, you're getting about 85%. At 0 degrees Fahrenheit, you're getting about 65%. So it's not ideal.
So it's lower, but it's not stopped.
It's not useless. Yeah, it's not a paperweight. It will still deliver power. But the one thing that can hurt the battery, that can damage the battery, is if you charge it when it's very cold.
Gotcha.
If you charge it when it's very cold, you could form lithium metal on the anode. That's called lithium plating. And it's kind of funny, but there's no lithium metal in a lithium ion battery. Oh. It's all lithium ions. So if you form lithium metal because you've charged when it's too cold, that will degrade the battery capacity.
Gotcha.
In our system, our BMS will not let you charge below freezing. So you can always discharge it, but if the temperature falls below 25 degrees Fahrenheit, it will not let you charge it unless it comes back over freezing. So there are heating solutions. We actually sell one, but there's all kinds of things you can do to just keep it above freezing. Yeah. You don't have to keep it toasty, but just above freezing.
Just slightly warm. Yeah. And I suppose if you've got power to charge a battery, you should have power to charge, or to power a little heating unit or something around it, just to kind of give it a little bit of warmth as well.
It doesn't take a lot of energy to keep it above freezing, especially if you insulate it. Then it hardly takes any energy at all. Some people, they just put in a compartment with a light bulb, and that's that. So yeah, we get that question a lot. I will put a little teaser out there that we have a solution coming out this year. That, in addition to the external solution, we will also have an internal solution for some of our batteries.
And particularly, I think one of the things I've said to people before is, if your main source of charging is solar, then in order to charge from the sun, you need some sunlight. So even if your overnight lows might get below freezing, as long as the sun comes up to start warming the system during the day, then the sun that's going to charge the batteries is the sun that's going to warm the batteries so they can be charged as well. So you kind of get the power coming in during the day anyway. You're not getting any solar at night when it's cold.
Right, that's it. I mean, there's heat coming in during the day, there's power coming in during the day, and then at night, if you can maybe use a little bit of the heat that you had during the day to keep it warm enough at night, insulate it well, there's all kinds of solutions.
And a lot of these things are things that you'd want to do with lead acid batteries anyway, because you don't necessarily want those to freeze.
That's right. No, that's the irony. Is you don't want that. You don't want freezing to happen to anything, even electronic components, inverters. Nothing works well when it gets really cold. But it means more for a lithium battery because you can't go to Costco and pick one up for a couple $100.
Yeah.
It is an investment. So that's why we're not going to let you do anything bad to it.
And it protects you. The BMS protects you and protects the battery from those temperatures.
Yep, that's right. I would say the chemistry, lithium iron phosphate, is the best protection in terms of catastrophic events. You don't get those sorts of events as easily with lithium iron phosphate. Yeah. But on top of that, what protects the investment is the battery management system.
That makes sense.
Yeah. So yes, so after the modules are sorted and then serialized and put into a bin, they are then assembled into a battery. They're bolted. The battery management systems, each of which have been tested, are then mounted onto the battery. And then the very last step before sealing the battery is we actually test every battery pack. Let's go take a look at that testing station.
That would be great.
So this is our battery test station. The last thing that happens before the lid gets glued onto the bin is that we test the function of the battery of the BMS and make sure it doesn't allow delivery of errant currents or it doesn't allow you to sustain what it's rated to. So let me get this one started. As you can tell, there's a lot of home-built stuff in this facility. You saw our welders, you saw our cyclers, our testers. This particular tester is automated so that we hit a button, and what it's going to do, it's going to allow basically a continuous current. Right now it's delivering 97.8 amps, and we want to make sure it can do this for over 30 seconds because it's supposed to be able to do this continuously from full to empty. Then the next step is going to push it up to about 120 amps, and it's supposed to deliver between 100 and 200 for 30 seconds. So we're gonna make sure that the BMS actually shuts down. Okay, so now it's just kicked up and it'll run like this for 30 seconds. And then you'll see the BMS shutdown light come on, indicating that it had shut down. A few seconds later, it will reconnect, and then it'll reconnect at a higher current, higher than 200 amps. And then we should see an immediate shutdown. And then finally, once it passes those tests, it goes into a charge cycle and makes sure that it can charge. And then if everything happens well, there's the BMS shutdown. If everything happens, then the green light will flash and we're ready to seal. And there's the reconnect. And this one's good to go.
And that has tested that the battery fulfills all of the requirements, that the BMS shuts off when it should and protects the battery, and that it can charge, and it leaves here fully charged.
This is a load tester, so it does all of the current tests, all the high current tests. So all the voltage tests and temperature tests are done on a different testing station. We've got a big load bank up here. This is for the high current testing.
Fantastic. So it looks now like the next step is to get that lid on the battery.
That's it.
Let's do it.
That's it.
So Dennis, once all the batteries have been made, they're all sitting here, they're getting clamped up to be really nice and secure and cure overnight. The last step is then packaging them and getting them shipped out to the customer. Can you tell us a bit about that?
That's it, yeah. So first we get them stickered, and then we get them bagged, and then we have to package them in a box for shipping. And we actually worked hard on this step because it's important that the battery arrives in very good condition.
Yeah.
And we worked with Earnest Packaging. They helped us develop a solution through sealed air. And here we actually have foam that we're making in the shape of our battery. So we've got these molds that were made custom for us by Sealed Air.
Wow.
And this is a two-part compound where they kind of mix, and then it grows into a foam that we sort of squeeze into our shape that we want.
So when these come out of the mold, these fit really tight around that battery.
Yeah, so it's we've got, they have to be UN rated boxes because we're shipping a, hazmat material,
yeah.
Technically. It's still considered hazmat. That's a whole other story. But anyway, yeah, so we've got the perfect size box, the perfect size foam, and it's a really nice packaging system that we have, and we ship for free. So that's not something you have to worry about. We get it in the box, we get it to you, and we don't add to the cost for you.
And I remember when ours arrived, I sort of opened the packaging, and it's really snug in that box. It really is nice and securely shipped.
Right, yeah, so the battery, of course, can take all kinds of vibration and impact. And so we've gone through all kinds of destructive testing.
Yeah.
But we want it looking brand new when it arrives. And so we definitely want the foam to be, if anything happens, if the box gets crushed, we don't want a blemish on the battery. So
and let's just talk about like orientation for a second, because we didn't touch on that earlier. Does it matter if the batteries get like turned upside down during shipping and all those kind of things?
Not at all. I mean, you can mount, once you get the battery, you can mount it however you want. You can mount it upside down. You can mount it on its side, on its edge. So there's no orientation. It's all squeezed in there. We've got foam inside the battery to absorb, any kind of impact and vibration. But at the same time, it's squeezed in there, so it doesn't matter what orientation you're in.
So and you can literally mount it upside down?
You can mount it upside down.
Wow.
I don't know why you would. I don't remember anyone who's ever mounted it upside down.
Certainly stacking them on their end or on their sides or whatever.
We've had all kinds of applications like that.
That's awesome. And then this new factory, obviously the output here, you're hoping is going to go up. How many batteries here are you producing?
Oh my goodness. From the last place, we've pretty much doubled, right off the bat. So we intend to double again, within the next year. So definitely this facility has been great for us to increase production. Right off the bat, the main benefit is we no longer have lead times. For a while we had, several week lead times. We had some folks that were a little impatient to get our battery, which is good. We like it that way. But now we actually have stock built up. We can ship same day.
So Mo, you are in charge of all of the inventory here and making sure that these batteries go out. This looks like a big operation you've got going on here.
Indeed it is, yeah. It can be difficult at times because things get shuffled around a lot, but I mean, we have a good team here to where we pay attention to what we're doing, so it's nice.
And how are you finding this new factory? This is pretty cool.
I love it. There's a lot more space. We can organize a lot better than our other warehouse where we were getting a little confused where we were placing things. Now we have different areas where we can actually separate different type of batteries, so it's nice to have all this floor space.
That's super cool. It looks really busy. There's a lot going on around here. How do you make sure that people get the right stuff?
I pretty much have certain people do certain tasks, so that way nobody's really get confused as far as how they're setting up pallets, how they're sending out batteries. It's nice to have more than just one person helping me on this side. So having a bigger team definitely helps, because then, again, not only my eyes are on things, but there's another set of eyes that double checks things so that everything's being done properly. So it's nice.
And do customers ever get the wrong batteries? Do you ever send out the wrong stuff?
Well, to my knowledge, we haven't sent out anything wrong more recently. I know in the past we have, but we've tried our best to perfect what we're doing now, and we've been doing great, so I'm happy about that.
Well, that's awesome. It looks like you got a lot here to get on with, so I won't take any more of your time, but thank you so much.
Thank you.
So Dennis, thank you so much for taking the time today to show us around the tour. I think this new factory looks phenomenal. Looks really exciting.
Welcome.
And I know you're still only a few weeks into this factory, but I'm sure in no time at all those shelves are going to be full. So if people still have more questions, how can they find out more?
Great question. You can go to our website at www.battlebornbatteries.com. You can email us at info@battlebornbatteries.com, or you can just call us in at the number that's on the website and talk to one of our salespeople. We can help you with technical questions, designing your system, setting up your system. Basically, any questions you have about lithium-ion batteries or the whole system, we are here to help.
That's awesome. And for everyone at home, I hope you enjoyed that video. If you did, make sure to hit that subscribe button and follow us on our journey as we continue around the US to visit all 419 national park units. See you next time.